Good afternoon, everyone. I'll start things off a little differently today. I'll begin with a short story. As Mr. Matsachek mentioned, I was here last year as well, and when I was here last year I talked to you about the application of general artificial intelligence in industrial settings. I showed you a specific product that we launched to market from the DataTalk platform family, the product called AI Alarm and Notify. After that talk, we demonstrated what that product could be used for: predictive maintenance, assistance with manuals, dispatcher support. And after the talk, there was quite a lot of interest. A fair number of people reached out to me, and we discussed the use cases together, and it always ended the same way. Everyone asked, "Tell us where you've actually deployed it. We want to see it. We want to see how it works, how it's used, and whether what you're saying is actually true." And I'm glad to be back here a year later to tell you that what I told you a year ago, I wasn't bluffing. It really works. That said, over that year, we had quite a thorny road getting the product to the finish line. And today, I'd like to share that journey with you. And it should give you a pretty clear picture of what this kind of product can be used for and where the technology is heading. Today I'd like to show you two interesting industry references using generative artificial intelligence. They should give you a pretty clear picture of what this kind of product can be used for and where the technology is heading. A lot has happened over the past year. AI has learned to handle many things it couldn't do a year ago. So I'm glad to say that many of the things you asked about last year, like automatic searching in schematics and similar tasks, we can now almost do. I think the use cases will be interesting for you as well. Let's get into it. AI in factory public address announcements. I chose this as a fairly unusual application, one where you wouldn't normally think of using AI, but the use case is actually quite elegant. The situation is this: a manufacturing facility has a long, continuous production line that must never stop. When a dispatcher identifies a problem, they announce it over the factory PA system. The challenge is that there are many foreign workers on site who don't understand well, so the announcements are often not understood. What we did was connect a Mac Mini to each microphone. It performs automatic speech detection and real-time translation. Whatever the dispatcher says is automatically displayed on large industrial screens placed throughout the factory floor, so everyone can immediately see what was announced. That was step one. Step two was automatic translation, because the facility employs many Filipino and Polish workers. So whatever the dispatcher says in Czech is automatically translated into English or Polish. And of course, once the application went live, the biggest issue we had to deal with was profanity filtering, which, I have to say, was quite entertaining. The richness of the Czech vocabulary in that department is remarkable. We'll have years of work just on that filter alone. But the application works quite nicely. And a quick note on why we used Mac Minis in an industrial environment. They're relatively affordable machines with excellent performance for running AI workloads. The second application is the Tunnel Assistant, a somewhat more serious project. It's an AI assistant for the Panenka-Libuchek tunnel complex on the D8 motorway. We focused on three key areas. The first was building an expert system for documentation and regulations. The tunnel requires handling a large number of different situations, and there are rules for everything. We uploaded tens of thousands of pages of documents into the system, and it can navigate the documentation extremely well, searching it accurately and delivering instant answers. The biggest advantage is that it can cross-reference multiple documents at once. It can automatically look into a fire report, a software project, and a pump manual simultaneously, and combine all of that information for you. You save hundreds of hours of searching through documentation. The primary purpose of the system is rapid response to emergency situations, supporting dispatchers and police officers in the event of a fire, accident, or unexpected incident in the tunnel. We're also beginning to explore its use as a maintenance assistant. The system knows the full state of the tunnel, what's active, what's been repaired and when, and it has access to all the documentation. Here you can see a real screenshot from the system, taken just a couple of weeks ago. I asked about the current state of the tunnels. The system automatically responded, "You have 23 active alarms." I asked what the problem was, and as you can see, the system doesn't list alarm after alarm individually. It gives me a very clean summary, automatically grouped by tunnel type and fault type. I look at it and think, that's odd. Pumping station, minimum pressure in the pipe. So I investigate. I ask what that pumping station is used for, and here you see the advantage. The system has access to all the tunnel data, not just the live data. It beautifully combines it with the documentation. It tells me what it's used for, where problems can arise when it fails, and it links that to the active alarms. The AI elegantly connects documentation data with live data and searches them contextually. In a large system, a dispatcher simply doesn't have time to access all that information quickly. A brief note on the technical side, this is critical infrastructure, so no data can leave the premises. We had to build a local server. For visualization, we use FactoryTalk View SE, with several ControlLogix controllers underneath. The project is quite large. We process over 11,000 tags, over 5,000 alarms, and thousands of pages of documentation. Key integration challenges included embedding the application directly within FactoryTalk View, so dispatchers don't need to switch to a separate tool, and automatic user authentication. The main technical difficulty was running a large language model locally, which required a very powerful server. The one thing we didn't anticipate was just how loud that server would be. Colleagues had to configure it remotely because it sounded like a rocket launching. We also put significant effort into response reliability, ensuring the generative AI answers factually and doesn't hallucinate. We have several methodologies in place for that. If you're interested in learning more, we've prepared a seminar together with our colleagues from Control Tech. Now, I had a great new product ready to show you, DataTalk Real-Time Dashboards. But while I was working on it, I received an email from Petr Mikshovsky. It included a notice from Rockwell stating that customers should not connect PLCs directly to the internet. Since we take security seriously, I thought, that can't be right. Why would anyone connect a PLC directly to the internet? I looked into it, and at that moment we found over 3,000 devices worldwide connected directly to the internet. Devices you could reach and download a project from. In the Czech Republic, that's just 3 companies. Most are in North America. I found plenty of understandable reasons why this happens: remote PLC programming, data access, dashboards. For all of these use cases, there's a simple solution. We have something called the OTIT Gateway, a platform that separates OT technologies like PLCs and sensors from the IT network. It's a device where you plug in the automation system on one side and connect to the IT network on the other. It ensures security and data transfer, speaking PLC protocols on one side and IT network protocols on the other. So it's straightforward to take data from a PLC and send it to SAP, Grafana, or Power BI in just a few clicks. How does the OTIT Gateway solve these common problems? If you want to program a PLC remotely, use My Access for secure remote access. If you want to see what went wrong, use Alarm and Notify, and check from your phone what issue occurred. If you want reporting, use Connect Log and Report, which pulls historical data and delivers reports as PDF or Excel files. If you want dashboards and production status, use Real-Time Dashboards. Live data from the PLC on one side, easy-to-build dashboards on the other. And if you use our DataTalk OTIT Gateway, you can mirror that data to other systems like Grafana or Microsoft Power BI securely, while keeping your OT and IT networks separated. The same applies if you need to push data into ERP or MES systems like SAP or Abra. I'd like to show a quick reference, a project at Skoda Auto together with Service Control, which supplies the logistics vehicles used in the plant. Skoda Auto has strict IT requirements. Each vehicle has an OTIT gateway installed, which reads data from the safety PLC in the vehicle and connects via Wi-Fi to Skoda's IT network. We send data via an MQTT broker to the visualization and upstream systems. The network also handles vehicle commanding and real-time control. The OTIT gateway provides secure connectivity between Skoda's IT network and the vehicle's technology network at the safety PLC level. That's a nice practical example. And that's everything from me. Thank you very much. If you have any questions, please find me. I'll be sitting over there at the table in the back. One of the areas we've been focused on for a long time is exactly this: data collection and its secure transfer to other technologies. So if that topic is of interest to you, please reach out. I didn't highlight them on purpose. I didn't want to give anyone bad publicity here. The majority are in North America, so that's somewhat reassuring. I thought about it and asked myself, why would anyone do this? And I found plenty of good reasons. It could be, I want to program the PLC remotely. I want to access the data. I want to build dashboards. For all of these problems, there is a simple solution. So let me do a quick run-through of how all of these things can be solved without having to connect the PLC directly online. We have something called the OTIT Gateway, a platform that separates your OT technologies, PLCs, sensors, and local systems from the IT network. It's a straightforward solution. A box where you plug the controller in on one side and connect to the IT network on the other. Installation takes just minutes. If you want to program a PLC remotely, simple. Put the box in place, use My Access, and you have secure remote access from anywhere. You can program, run diagnostics, and make edits. If you want to see what went wrong, use Alarm and Notify. With securely separated networks, any problem that arises in the PLC automatically triggers a notification via SMS, email, WhatsApp, or whatever you prefer. You can check from your phone or computer exactly what happened. If you want reporting, use Connect Log and Report. It connects to the PLC, pulls historical data, and delivers reports as PDF or Excel. If you want dashboards and production status, use real-time dashboards. Live data from the PLC on one side, easy-to-build dashboards on the other. Everything in just a few clicks. And using the DataTalk OTIT gateway, you can mirror that data securely to other systems: Grafana, Microsoft Power BI, SAP, Abra, or any other ERP or MES system, while keeping your OT and IT networks fully separated. The key point is always to do this securely, never by connecting the PLC directly to the internet. And on the other side, it understands the IT network, so data from a PLC can go straight to SAP, Grafana, or Power BI. Here's a short reference to show how this works in practice. This is a project we carried out together with Service Control, which supplies logistics carts used inside Skoda Auto. As you can see, this is what the visualization looks like. These carts operate within Skoda Auto, which has strict requirements for its IT systems. Each cart has an OTIT gateway installed. On one side, it reads data from the safety PLC inside the cart. On the other side, it connects via Wi-Fi to Skoda's IT network. Through an MQTT broker, we send data to the visualization and to the higher-level systems. The carts are also commanded through this network, meaning real-time control runs through it as well. The OTIT gateway provides secure connectivity between Skoda's IT network and the cart's local technology network at the safety PLC level. A nice, practical example of how this can work in a real industrial environment. And that's everything from me. Thank you very much. If you have any questions, please find me. I'll be at the table in the back. One of the areas we've been working on for a long time and have quite a lot of experience with is exactly this: data collection and the secure transfer of data to other technologies and networks. So if this topic interests you, don't hesitate to reach out. Here's a short example of how this can work in practice. OTIT Gateway in Škoda Auto. This is a project we carried out together with Service Control, which supplies the logistics carts. Here you can see what the visualization looks like. These carts operate inside Škoda Auto, which has quite strict requirements for its IT systems. Each cart has an OTIT gateway installed. On one side it reads data from the safety PLC inside the cart, and on the other side it connects via Wi-Fi to Škoda's IT network. Through an MQTT broker, we send data to the visualization and to the higher-level systems. The carts are also commanded through this network, meaning real-time control runs through it as well. The OTIT gateway ensures secure connectivity between Škoda's IT network and the technology network inside the cart at the safety PLC level. A nice, practical example. And that's everything from me. Thank you very much. If you have any questions, I'll be at the table in the back. If this topic interests you, don't hesitate to reach out. Here's a quick example of how this works in practice. The OTIT Gateway at Škoda Auto. This is a project we carried out together with Service Control, which supplies the logistics carts used inside the plant. Here you can see the visualization. These carts operate inside Škoda Auto, which has strict IT requirements, so this is how we approached it. Each cart has an OTIT gateway installed. It reads data from the safety PLC inside the cart and sends it via Wi-Fi to Škoda's IT network. Through an MQTT broker, we send data to the visualization and to the higher-level systems. The carts are also commanded through this network for real-time control. The gateway provides secure connectivity between Škoda's IT network and the cart's local technology network at the safety PLC level. A nice, practical example of how this can work in a real production environment. And that's everything from me. Thank you very much. If you have any questions, you'll find me at the table in the back. And that's everything from me. Thank you very much. If you have any questions, please find me. I'll be sitting at the table in the back. One of the areas we've been focused on for a long time and have quite a lot of experience with is exactly this: data collection and the secure transfer of data to other technologies and networks. So, if this topic interests you, don't hesitate to reach out.